In the world of science, DNA is supposed to be the ultimate truth. It identifies criminals, proves paternity, and maps the blueprint of life itself. But what happens when DNA lies? What if a person's own body contains not one genetic code, but two? This isn't science fiction. It's the strange reality of chimerism, a rare phenomenon where two sets of DNA exist within the same individual. For some, it remains hidden forever. For others, it surfaces in shocking and life-altering ways. Imagine a mother giving birth, only to be told the children aren't hers because her DNA doesn't match. Picture a man accused of a crime he didn't commit because the DNA left at the scene belongs to his other self. Chimerism blurs the boundaries of identity, forcing us to ask, what does it really mean to be one person? The condition often begins before birth, when two embryos fuse into one. The result is a single human carrying the genetic legacy of two siblings, sometimes with subtle clues like mismatched eye colors or unusual birthmarks, but often invisible until DNA tests reveal the hidden truth. In this episode, we dive into the science of human chimeras, the mystery of how one body can carry two genetic identities. From courtroom dramas to medical marvels, from mythology to cutting-edge genetics, chimerism challenges everything we thought we knew about DNA, individuality, and the very definition of self. For decades, DNA has been treated as the ultimate fingerprint of life. Courts rely on it to convict criminals. Parents depend on it to prove family bonds. Scientists use it to map ancestry across centuries. In the public mind, DNA equals truth. But what if DNA lies? What if the very code we think of as absolute turns out to be more complicated? For some people, this shocking reality emerges when their DNA test does not match what logic and biology say it should. Cases have surfaced where mothers were told their children could not possibly be theirs because the DNA didn't align. In one instance, a woman nearly lost custody of her own kids when blood samples failed to confirm she was their biological mother. Only later did deeper testing reveal that her reproductive organs carried different DNA than her blood. There are also men accused of crimes who claimed innocence, only for police to find DNA evidence at the scene that matched them and didn't. The confusion stems from the fact that one person can, under rare circumstances, have two entirely separate genetic identities. This phenomenon is called chimerism. It undermines the bedrock assumption that every cell in our body carries the same DNA. Instead, it reveals that identity can be split, layered, and hidden in ways that challenge science, law, and philosophy alike. The paradox is unsettling because DNA was supposed to be a single truth. It was the thing that made us us. Chimerism forces us to confront a new reality, that even the building blocks of life may not be as simple or singular as we once believed. Chimerism is one of biology's strangest puzzles. At its core, it means that a single person carries more than one complete set of DNA. Instead of every cell in the body sharing the same genetic blueprint, patches of cells belong to one genetic identity while others belong to another. Most people assume they are genetically uniform, that their blood, hair, saliva, and skin all tell the same story. For chimeras, that assumption falls apart. A cheek swab may say one thing, while a blood test says another. The body holds two truths at once. This phenomenon is extremely rare, but it comes in different forms. The most dramatic is embryonic fusion, when two fertilized eggs, twin embryos, merge in the earliest days of life. Instead of developing as two separate siblings, they fuse into one. The result is a single individual carrying the DNA of both. Another form is microchimerism, where cells from one person migrate into another and remain for life. The most common example happens during pregnancy. Mothers carry a small population of their baby's cells long after birth, while children may retain cells from their mothers. These fragments of genetic sharing blur the line between individuals. There is also iatrogenic chimerism, which arises after medical procedures. Bone marrow transplants, for instance, can give a person a new set of blood-forming cells with DNA entirely different from their own. In such cases, a patient may be their old self in one organ and a genetic stranger in another. Chimerism is often confused with mosaicism, but they are not the same. In mosaicism, mutations during development cause variations of DNA that all stem from the same embryo. In chimerism, the difference is deeper. It is the coexistence of two separate genetic lineages in one body. In many cases, chimerism leaves no obvious trace. People may live their entire lives never knowing they carry two identities. It is only through accidents of testing, illness, or investigation that the secret comes to light. Chimerism challenges our deepest assumptions about individuality. If one body can contain two genomes, where does one identity end and another begin? Science sees it as a biological oddity. Philosophy sees it as a mystery about the nature of self. The most dramatic form of chimerism begins before birth, in the hidden world of early development. When twins are conceived, they usually grow as two distinct embryos. But sometimes, within days of conception, they fuse. What should have been two siblings becomes one person, carrying the genetic code of both. This is known as embryonic fusion, and it creates some of the most striking cases of human chimerism. Instead of each twin living independently, their cells combine into a single body. The result is not a monster or a half-formed twin, but a single individual whose body is a patchwork of two DNA lineages. In some cases, the evidence is visible. One patch of skin may be darker than another. Hair may grow in two distinct colors. Eyes may differ, one blue and one brown. These outward signs reflect the genetic mosaic stitched together at the cellular level. But in many cases, the fusion leaves no obvious trace. The two sets of DNA may hide in different organs. Blood might reflect one twin, while the reproductive system carries the other. A woman may unknowingly carry her sibling's DNA in her ovaries, passing on children who genetically match her vanished twin more than herself. This is where the idea of the vanishing twin becomes real. One embryo does not die and disappear. It lives on, silently, as part of the surviving sibling. Their existence is preserved not as memory, but as genes woven into another person's body. For those who discover it, the revelation can be life-changing. To realize you are not just yourself, but also the genetic echo of a sibling never born is both unsettling and profound. It blurs the line between individuality and kinship. Embryonic fusion explains why some cases of chimerism seem so impossible. How can a mother not match her children? Because her eggs carry the DNA of her twin. How can two samples from the same person give different genetic results? Because within her lives, not one genome, but two. The embryonic fusion mystery reminds us how fragile and flexible development can be. Two lives may merge into one, not by choice or miracle, but by the silent logic of biology. The result is a living paradox: one body, two blueprints, one life containing the shadow of another. Not all chimeras live with obvious markers. Many carry their dual DNA in silence, never suspecting they are anything other than ordinary. Yet for some, the body whispers its secrets. These whispers can appear as subtle anomalies, tiny clues that suggest something more unusual lies beneath the surface. One of the most striking signs is heterochromia, where each eye has a different color. To most, it looks like a charming quirk, a unique feature. But in some chimeras, it is the outward display of two distinct genetic blueprints existing side by side. One eye follows one genome, the other a second. Another visible marker is patchy pigmentation of the skin. Some individuals have large streaks or patches of different skin tones, almost like an internal map of their cellular origins. In rare cases, even the hair follows this divide. One side of the head sprouting blonde strands, the other dark brown. These color splits are not dye jobs. They are biological boundaries drawn by DNA itself. But not all clues are visible. For many, chimerism hides until reproductive mysteries reveal it. Consider a woman who gives birth only to find her DNA does not match her children's. At first, doctors suspect fraud, surrogacy, or even theft. But deeper analysis shows the truth. The eggs that produced her children came from the DNA of her twin within, not from the DNA circulating in her blood. She is both the mother and, genetically, the aunt of her own children. Other cases emerge in medical testing. A man may give a cheek swab that says one thing, then provide a blood sample that says another. In his saliva, one genome dominates. In his blood, another takes the lead. He is both, and neither fully. To law enforcement or paternity courts, such results are baffling, leading to accusations of deception until science explains the anomaly. Sometimes the clues show up in medical procedures. Imagine needing an organ transplant and finding out that one part of your body rejects the organ while another accepts it, because two different immune systems coexist. In some chimeras, the body behaves as if it is hosting both a donor and a recipient simultaneously. There are even rare stories of people with two distinct blood types, a condition only possible through chimerism. Blood drawn from one arm may test as type A, while blood from the other arm tests as type O. For transfusions, this is not just curious, but potentially life-threatening if not recognized in time. The most dramatic cases involve reproductive chimerism. These are the mothers whose wombs carry the DNA of their twin, or fathers whose sperm carries a code different from the DNA in their blood. For them, parenthood becomes a legal and scientific puzzle. Their children are theirs in every way: love, nurture, biology of conception, but the genetic paperwork tells a stranger's story. The emotional toll of such revelations is profound. Imagine standing in a courtroom accused of not being the parent of your own children because the lab report says so. The betrayal feels almost supernatural. Only the hidden twin inside, the vanished embryo fused in the womb, can explain it. Yet most chimeras remain undetected. They move through life with no visible patchwork, no mismatched eyes, no legal battles. Their dual DNA lives quietly in their organs, muscles, or reproductive cells, invisible unless modern sequencing pulls it into the light. Science suspects there are many more hidden chimeras than the handful of dramatic cases we know. The body, then, can be both subtle and flamboyant in revealing chimerism. For some, it writes the truth across the skin and eyes. For others, it hides the truth deep in the tissues, waiting for a genetic test to expose it. In either case, the clues remind us that identity is not always uniform, not always singular, and not always visible to the naked eye. In mythology, creatures like the chimera were marked by their hybridity. Lion, goat, serpent fused into one terrifying form. In reality, the marks can be gentle: a stripe of skin, a pair of mismatched eyes, or children who don't match. Biology whispers what myth once shouted, that the boundaries of self are not as firm as we imagine. And sometimes the greatest clue is not physical at all, but emotional. The shock and disbelief when someone learns they are not genetically singular. The human instinct is to see ourselves as one, indivisible. To realize you are two is to face a mirror that reflects not one self, but two hidden legacies woven together. When most people hear DNA test, they think of certainty. It is the evidence that convicts criminals, the proof that determines paternity, the gold standard in science and law. But chimerism has shattered that certainty in some of the most shocking legal battles ever recorded. One of the most famous cases involved a woman named Lydia Fairchild in the United States. In 2002, she applied for public assistance after separating from her partner. As part of routine procedure, she had to undergo DNA testing to confirm that the children she claimed as hers were biologically related. To her horror, the test results declared she was not their mother. Officials accused her of fraud and surrogacy scams. Lawyers pressed her to admit she had stolen or illegally adopted the children. In court, she was treated as if she were a criminal. But Lydia knew the truth. She had carried those children in her womb, given birth to them, and raised them. How could DNA deny her motherhood? The answer came only after a geneticist familiar with chimerism intervened. Additional testing revealed the shocking truth. Lydia's ovaries carried a different set of DNA than her blood. The children matched the DNA of her twin within, an unborn sibling who had fused with her in the womb. She was both the mother and, genetically speaking, the aunt of her own children. This case stunned the courtroom. The system built on the assumption that DNA never lies had to admit defeat. Lydia Fairchild was officially recognized as her children's mother, but only after enduring years of humiliation, fear, and legal battle. Another striking case emerged in Boston, where a woman named Karen Keegan underwent testing in preparation for a kidney transplant. Doctors searched her family for a donor, but DNA results revealed something shocking. Her own children did not match her genetic profile. Her body told one story, her children another. Like Lydia, Karen turned out to be a chimera. Her reproductive system carried DNA different from her blood. She had passed on the genes of her hidden twin. These are not isolated events. Around the world, similar cases have baffled courts and devastated families. In some instances, mothers nearly lost custody of their children. In others, fathers were accused of infidelity or surrogacy fraud. Each time, DNA, the supposed truth machine, was undermined by the quiet presence of chimerism. Chimerism has also entered the world of criminal justice. Imagine police investigating a crime scene where DNA evidence is found. The sample points to a suspect, but further testing reveals the suspect's DNA is inconsistent, different in blood, saliva, and hair. Law enforcement is left confused, unable to determine how one man could be two people at once. Such cases reveal a terrifying possibility. An innocent person could be accused based on one set of DNA, while another set inside their body might tell a different story. The legal assumption that one person equals one genome collapses in the face of chimerism. These courtroom dramas force us to ask difficult questions. If DNA can contradict itself, what does it mean for justice? Should DNA be treated as absolute evidence, or must it always be paired with broader context? The law was built on certainty, but chimerism proves that certainty is not guaranteed. For the families caught in these storms, the battles are not just legal, they are deeply personal. To be told you are not the parent of your own children is more than an accusation. It is an assault on identity. For the children, too, the consequences are profound. Their very sense of belonging is shaken when science says their parents are not their parents. Chimerism turns DNA from a trusted ally into a potential betrayer. It can pit mothers against courts, fathers against suspicion, and individuals against their own bodies. Yet each case that surfaces sheds more light on the hidden reality that chimeras are out there, living quietly until a DNA test exposes them. In the end, these legal dramas remind us that DNA is powerful, but it is not infallible. Behind every sample is a human story, one that science is still learning to interpret. For some, the courtroom becomes the stage where identity itself is put on trial, and the verdict depends on recognizing that one person can, in fact, be two. Beyond the courtroom, chimerism carries profound consequences for medicine. It complicates how doctors test, diagnose, and treat patients, often in ways that can determine life or death. One of the most surprising forms is iatrogenic chimerism. Chimerism acquired through medical treatment. Bone marrow transplants are the clearest example. When a patient receives marrow from a donor, their body begins producing blood cells with the donor's DNA. From that moment on, their blood no longer reflects their original genome, but that of another person. In effect, they become part chimera. This creates unique challenges. Imagine a patient who undergoes such a transplant and later has blood drawn for genetic testing. The lab may conclude the sample belongs to the donor, not the recipient. Forensic identification, paternity testing, and even medical records can be thrown into chaos by this dual DNA. Organ transplants can also create partial chimeras. Donor cells sometimes migrate into the recipient's tissues, surviving for years. This can lead to unexpected blends of genetic identity across different parts of the body. A cheek swab may reflect one profile, while a liver biopsy reveals another. Even pregnancy introduces chimerism. Through microchimerism, fetal cells cross the placenta and take root in the mother's body, sometimes lasting decades. Mothers may carry traces of their children's DNA in their blood, skin, and organs. Likewise, children may carry cells from their mothers or even from older siblings through maternal transmission. This subtle blending of lineages means many of us may be chimeras without ever knowing it. For medicine, these realities complicate the assumption that a single DNA sample tells the whole story. A doctor may test a patient's blood and miss critical mutations present only in other tissues. Diseases may hide because the tissue sampled does not carry the genome responsible. Precision medicine becomes less precise when DNA itself is fragmented across identities. Chimerism also raises ethical questions in organ donation and forensics. Should medical records note when a patient has multiple DNA profiles? How should hospitals handle the possibility of misidentification during treatment? If a crime is committed and DNA evidence points to a donor instead of a recipient, who bears responsibility? In some ways, chimerism even offers benefits. Studies suggest that microchimeric fetal cells in mothers may assist with tissue repair, like tiny biological helpers lingering long after birth. Others suspect they could play roles in autoimmune disease, making the relationship both protective and risky. Medical researchers are fascinated by chimerism because it forces them to rethink identity at the cellular level. A body may not be one story, but many, stitched together in ways we are only beginning to understand. For patients, this is both unsettling and empowering. It means their biology holds mysteries even science cannot fully explain. The medical implications of chimerism ripple far beyond the individuals who experience it. They touch questions of transplant ethics, genetic testing, reproductive health, and even how we define the boundaries of one human being. For medicine, the chimera is not just a rare oddity. It is a mirror reflecting the complexity of every body. Long before modern genetics uncovered human chimerism, the idea of blended beings haunted human imagination. Myths across cultures tell of creatures that were part one thing and part another, hybrids born from the collision of worlds. These stories, though fantastical, reflect humanity's deep fascination with the boundaries of identity. The most famous of these legends comes from ancient Greece, the chimera. Described as a fire-breathing monster, it was said to have the head of a lion, the body of a goat, and the tail of a serpent. It was a creature of contradictions, feared not only for its form, but for what it represented, the collapse of natural order into chaos. The word chimera endures today as the symbol of hybridity. Other cultures also told tales of dual beings. In Hindu mythology, composite creatures like Narasimha, half man, half lion, embodied divine paradoxes. In Egypt, gods like Anubis, part human and part jackal, blurred lines between species to symbolize transitions between worlds. To ancient people, these forms were not accidents, but symbols of power, transformation, and danger. Even folklore closer to our own time preserves echoes of chimerism. Stories of people with two souls, or of twins joined invisibly in one body, appear in medieval and indigenous traditions. These tales spoke to fears of hidden identity and unseen doubling, fears that mirror the modern shock of discovering a biological chimera within. In literature, too, the chimera became metaphor. Poets use the term to describe illusions, impossible dreams, or unattainable fusions. To call something a chimera was to call it both wondrous and dangerous, a fantasy that could not or should not exist. Modern science, however, has stripped away the flames and serpents to reveal something subtler but no less remarkable. Two sets of DNA living in one body, yet the resonance with mythology remains powerful. Just as the chimera in myth was feared as unnatural, the discovery of human chimerism unsettles our assumptions of order. Some patients describe their shock at diagnosis in mythological terms. They feel haunted by the ghost of a twin, carrying another identity within themselves. Others see it as a strange gift, a living reminder that they are more than one story, more than one origin. The myth of the chimera offers them language for something science only recently named. The cultural roots of chimerism remind us that humans have always wrestled with questions of identity and doubleness. Where does one being end and another begin? What happens when categories collapse and boundaries blur? Myth answered with monsters, science answers with DNA. But the mystery at the core, the fear and wonder of hybridity, remains the same. At its heart, chimerism is not just a medical puzzle, it is a challenge to how we define the self. For centuries, identity was seen as simple: one body, one soul, one genetic code. Chimerism disrupts that model. It shows that even at the cellular level, individuality is not always singular. DNA has long been treated as the ultimate marker of identity. It convicts criminals, unites families, and defines ancestry. Yet chimeras demonstrate that DNA is not always uniform, not always absolute. If one person can carry two distinct sets of DNA, then who are they, legally and biologically? For the justice system, the implications are profound. A person may be innocent and guilty at the same time, depending on which DNA sample is tested. Mothers can be told they are not mothers, and fathers may be accused of fathering children who are genetically their own. The law struggles when its gold standard wavers. Philosophy, too, is drawn into the debate. If identity is more than biology, what role does DNA truly play in defining who we are? Consciousness, memory, and personality remain singular, even when genetics are not. Chimerism forces us to separate the concept of self from the blueprint of cells. For medicine, the question is practical. Doctors cannot assume that one tissue sample represents the whole patient. They must recognize that identity is layered and that treatment must account for the possibility of multiple genomes coexisting. This is not just about curiosity. It can determine the success or failure of care. Even in society, chimerism challenges notions of truth. In a world where DNA tests are sold for ancestry, for paternity, even for entertainment, chimeras remind us that the results are not always simple. A single swab cannot always capture a person's full biological story. Chimerism also sparks ethical reflection. If someone contains the DNA of a sibling absorbed before birth, are they one person or two? Do they carry within them the genetic echo of another life that might have been? These questions, once mythological, now demand scientific and moral consideration. In the end, the science of identity that emerges from chimerism is both humbling and liberating. It humbles us because it proves that our categories, self, other, parent, child, are more fragile than we imagined. It liberates us because it shows that identity is not confined to a single definition. We are not just DNA, we are stories, consciousness, and connections, layered in ways that no test can fully measure. For much of history, chimerism went unnoticed. Without modern tools, doctors had no way of knowing that one body could contain two genetic codes. It was only with the rise of DNA testing in the late 20th century that the first shocking cases emerged, cases that overturned assumptions in courts, clinics, and families. Early discoveries often came by accident: a mother who failed a maternity test, a man whose blood type did not match his tissues. Each case forced scientists to look deeper, realizing that the body could hold secrets invisible to the naked eye. Advances in genetic sequencing have since transformed the search. Where once a single blood sample was assumed to tell the whole story, scientists now know to test multiple tissues: blood, saliva, hair, skin, and even reproductive cells. Each sample can reveal a different genome, exposing the hidden chimera within. Large-scale genetic studies have also uncovered surprising rates of microchimerism. By sequencing maternal and fetal cells, researchers found that nearly all mothers carry some of their children's DNA for decades. In turn, children carry fragments of their mothers. Chimerism, once seen as bizarre, may be far more common in subtle forms. Cutting-edge research is exploring how these cells behave. Do fetal cells help repair maternal tissues after pregnancy? Do they play a role in autoimmune disorders by confusing the immune system? Are they silent passengers or active participants in health and disease? The answers remain elusive but promising. Technological progress has also raised new ethical dilemmas. Direct-to-consumer DNA kits, marketed for ancestry or health, sometimes reveal unexpected genetic splits. Families discover children who do not match, or siblings who appear half-related. Behind the surprise, chimerism may be the hidden explanation. Researchers are now cataloging cases to build a clearer picture. Every documented chimera expands understanding of how common the condition might be. Already, scientists suspect that many more exist undetected, their dual DNA lying quietly until the right test exposes it. The discovery of chimerism is not just about rarity, it reshapes biology itself. It teaches scientists that identity is more fluid than fixed, that the human body is capable of carrying multiple lineages, and that genetic truth is not always singular. The more we learn, the more chimerism evolves from curiosity to key insight. It is not merely an anomaly, it is a window into how our bodies grow, adapt, and sometimes defy categories altogether. Research is only beginning, but each revelation pushes us to reconsider what it truly means to be one. Chimerism leaves us with a haunting question: what does it mean to be one person? For most of us, the answer feels simple: one body, one identity, one genetic code. Yet chimeras remind us that even the foundation of life is more complicated than we imagine. To carry two sets of DNA is to live as a paradox. One part of the body belongs to one lineage, another to a different one. In some cases, motherhood or fatherhood becomes tangled, with children who are both biological offspring and genetic nieces or nephews. In others, the truth is invisible until revealed by a test. For patients, the discovery of chimerism can be unsettling. It challenges their sense of individuality, sometimes leaving them to wonder, am I one person or two? But for many, the answer is empowering. They are both and neither. They are themselves, enriched by the silent echo of another genome within. Science, too, is forced to redefine the self. Identity cannot be reduced to DNA alone. Consciousness, memory, relationships, and lived experience carry equal weight. Chimerism proves that biology is not destiny. It is one thread in the complex fabric of human identity. The lessons ripple outward. Courts must rethink how evidence is weighed. Medicine must adapt to layered identities in diagnosis and treatment. Philosophy must embrace the possibility that the self is not singular, but multifaceted, capable of holding more than one truth at once. In myth, the chimera was feared as a monster, a violation of nature's rules. In reality, human chimeras are ordinary people living extraordinary biological stories. They are not monsters, they are mirrors, reflecting the complexity and resilience of life itself. Ultimately, chimerism reminds us that identity is not fixed, but fluid. We are not defined by a single test, a single sample, or even a single genome. We are defined by the sum of our parts, biological, emotional, and spiritual. The self is not reduced by duality, it is expanded by it. So, when we ask, how can one person be two people at once? The answer is both scientific and philosophical. They can because life itself is not bound by simplicity. They can because the human story has always been one of multiplicity, connection, and paradox. And they can because being human has never been about uniformity, but about the mysterious, layered truths that make each of us unique.